What is the multiple of a number? Multiple of a number is the number obtained by multiplying natural numbers to any given number. For instance, if you need to find what are the multiples of 13, so we can write down the multiple table of 13, like 1 13s are 13, 2 13s are 26, 3 13s are 39, 4 13s are 52, 5 13s are 65, and so on. So all these numbers like 13, 26, 39, 52, 65, 78, 91, 104, all these are said to be the multiples of 13. And there are infinite number of multiples of 13. So having understood what is the meaning of the word multiple, now let us discuss what is the meaning of LCM. LCM, or the lowest common multiple or the least common multiple of two or more numbers, is the smallest, lowest, least number common to all the multiples. For instance, the first method to find the LCM is by listing the multiples. For example, what is the LCM of 3 and 4? So we are going to first of all write down the multiples of 3. So we have 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27, 3 10s are 30, and so on. And then we are going to write down the multiples of 4. So the multiples of 4. So we have 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6s are 24, 4 7s are 28, 4 8s are 32, 4 9s are 36, 4 10s are 40, 4 11s are 44. We can keep on writing. Now we are interested in knowing what are the common multiples. The common multiples. So the common multiples are all those numbers which are common to both the lists. For example, the number 12 is common to both the tables. Then the number 24 is common to both the tables. So the common multiples are 12, 24, and if you extend the list, you'll also get 36 and other numbers. But what is the least common multiple, the lowest common multiple? And the smallest number is 12. So the least common multiple is 12. So this is the first method. It is by listing the multiples. In method number 2, we can find the LCM of two or more numbers by prime factorization. So let us see how to find the LCM of 10 and 15 by prime factorization. So first of all, we are going to write 10 as the product of prime numbers, which is 2 5s are. And then we are going to write 15, the second number, as 3 5s are. And then we are going to write down what is the highest common factor. So which number is common to both the products? So we have 5 is common to both the products. So the highest common factor is 5. Then we are going to write down the uncommon factors, or the factors which are not common to both these products, and they are 2 and 3. So 2 and 3 are the uncommon factors. So 2 3s is 6. So the least common multiple of 10 and 15 is this number, the HCF, and this number, the uncommon factor. So that is 5 multiplied by 6, and that is 30. So if you write down the table of 10 and if you write down the table of 15, the smallest number which is common to both the tables is 30. 10 3s is 30, while 15 2s is 30. Let us do another example. What is the LCM of 4, 6, and 8? So this time we have more than 2 numbers. And again we are going to use the prime factorization. And we are going to write down the prime factors of 4. which is 2 and 2. 2 2s is 4. And then 6, and we can write 6 as 2 3s are. Then we have 8, which is 2 multiplied by 2 multiplied by 2. So first of all, we are going to write down what is the common factor. The highest common factor means the number that is common to all the lists, all the products, and that is 2. So 2 is the highest common factor of these numbers. So in order to find the LCM by this method, we find the HCF first. Then what we do is, since there are 3 numbers, we are going to write down common factor in exactly 2. Exactly 2 numbers. It means the number which is not common to all the 3, but it is common to exactly 2 of the numbers. For instance, this 2 is common to 4 and 8. It is not common to all the 3. So we are going to write down a 2 over here. If there are no such numbers, you can write down 1. And then we are going to write down the uncommon factors. Uncommon factors. And that is the number which has not been underlined or not been circled, which is this number 3. So this 3 is uncommon factor. In order to find out the LCM, we are going to multiply this HCF, this common factor in exactly 2, and the uncommon factor. So 2 multiplied by 2 multiplied by 3 is 12. So the LCM of 4, 6 and 8 is 12. Let's do another example. Find the LCM of 4, 6 and 8. So we're going to write down the prime factors of 4, which is 2 multiplied by 2. Then we're going to write down the prime factors of 6, which is 2 multiplied by 3. And then the prime factors of 8, which is 2 multiplied by 2 multiplied by 2. So first of all, we're going to find out the HCF, the common factors in all the 3. And that is 2. 2 is present in all the 3 numbers. Then we're going to write down common factors in exactly 2. Means the factors which are not common to all the 3, but they are common to 2 of the numbers. For instance, this 2 is found in 4 as well as in 8. So the common factor in exactly 2 numbers is 2. If there is no such common factor, you can write 1. And then we have uncommon factors. Uncommon factors. Uncommon factors means the factors which are not common to all the 3 or even 2. For instance, this 3 and this 2, they are totally uncommon. So we are going to multiply the 3 and 2, and that is 6. So in order to find the LCM, we first find the HCF, then we find common factors in exactly 2, and then the uncommon factors, and then we multiply all the 3 numbers. So we are going to multiply this 2, and this 6. So 2 multiplied by 2 multiplied by 6. So 2 2s is 4, 4 6s is 24. So the LCM of 4, 6 and 8 is 24. Then we have another method which is called the modified prime factorization. So in this is the quickest possible method to find the LCM of 2 numbers or more than 2 numbers. So let us see how do we do this. So find the LCM of 8, 14 and 18. So we are going to write down 8, 14 and 18 all together. And then starting with the smallest prime number 2, we are going to see if these 3 numbers or at least one number is divisible or not. So we know 2 4s is 8, and even 14 goes in the table of 2. So 2 7s is 14 and 2 9s is 18. So we should divide in such a manner. Again, in the table of 2 we have 4, but we do not have 7 or 9. So since at least one number is divisible, we are going to write down this 2. So we can write down 2 2s are 4, but just copy down 7 and 9 as they are. Okay. And again, we can divide this 2 by 2. So we are going to take 2 for the third time, and we can write down 2 ones are 2, but bring down the 7 and 9 as they are. And then, since none of the numbers are divisible by 2, we should try for 3. But 7 and 9 are not divisible by 3. No, it's 9. 9 is divisible by 3. So we should take 3. 3 3s are 9. And we are going to bring down 1 and 7 as they are. And again, 3 1s are 3. And bring down the 1 and 7 as they are. And then we shall directly go for 7. 7 1s are 7. And bring down the 1 as they are. And when we get 1 in the last line, all the numbers are 1, then we are done with this prime factorization. So the LCM of 8, 14 and 18 is 2 multiplied by 2, multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 7. So just multiply all these numbers together. So we have 2 2s are 4, 4 2s are 8, then we have 3 3s are 9, and then we have 7. So we know 8 9s is 72, and 72 multiplied by 7. So 2 7s are 14, 1 carry, 7 7s are 49, plus 1 is 50. So 504 is the least common multiple of 8, 14 and 18. Thanks for watching.